Okay, on our next example, we're going to use a linear inequality in an application problem. Number 76 says Trent earned scores of 66, 84, and 72 on 3 chapter tests for a certain class. His homework grade is 60, and his grade for a class project is 85. The overall average for the course is computed as follows. This is what the instructor has in the syllabus. Okay? The average of the 3 chapter tests makes up 50% of the course grade. That's like for you guys in our college algebra class, actually. Homework accounts for 20% of the grade. The project accounts for 10%. And the final exam accounts for the remaining 20%. What scores can Trent earn on the final exam to pass the course if he needs a C or better? And FYI, the same as our grading scale, a C or better requires an overall score of 70 or better, and 100 is the highest score that can be earned on the final exam. So it says, assume that only whole number scores are given. Now, what we're going to do is we're going to calculate this weighted average. And the way that this is going to work is you're going to take 50% of the chapter tests. So let me write this as 50% of the tests. If we add that to 20% of the homework, so 0.2 or 0.20 of the homework scores, added to 10% of the project, added to, so far we have 50%, 20%, 10%, that all adds up to be 80%. So the remaining 20% is going to be his score on his final exam. Okay? Now, Trent wants this average to exceed a 70. He wants this average to be greater than or equal to a 70, but he can't get any better than a 100, right? Okay? But he wants his average to be greater than a 70 or equal to a 70. He'd be fine to slide right on by with a 70. Okay? Now, what we first need to do is get the average of the test scores. Okay? So we're going to average together the 66, the 84, and the 72. Remember, to average 3 things, you add them up and divide by 3. Okay? So, instead of writing 50, I'm just going to drop the 0 off of there and write 0.5. And the average of the 3 tests, 66 plus 84 plus 72, and then divide all that by 3, gives you a test average of 74. Okay? It also told us that for the homework, which accounts 20%, he has a 60 on his homework. Uh-oh. All right? Now, he made an 85 on the class project. That accounts 10%, so 0.1 times his project score. We're going to add that to 0.2 of his final exam score. So maybe we'll just call that X. Okay? We're going to let X be equal to the score on his final exam. Now that can't be any better than 100, so that's going to be our upper bound here for his final exam score. But let's figure out what's the minimum score he can make on his final to make sure that his average is at least a 70. All right, so let's bring down the 70. Okay, the less than or equal to symbol. And now we have 0.5 times 74 is 37. Plus 0.2 times 60 is 12. Plus 0.1 times 85 is 8.5. then we have plus 0.2 times x. All right, so when we add up 37 plus 12 plus 8.5, we get 57.5. And then let's bring down the plus 0.2x. Here I'm going to subtract 57.5 from both sides of my inequality. I got to scroll a little bit here. 70 minus 57.5 is 12.5. Okay, remaining on this right-hand side is a 0.2x. Now I'm going to divide both sides by 0.2. Okay? And so, the score on his final exam needs to be greater than or equal to 12.5 divided by 0.2 is 62.5. Okay? So he needs to make at least a 62.5, okay? But like we said, on this final exam, it said in the paragraph above, the best you can get is a 100. So we're going to say his final exam needs to be somewhere in between a 62.5 and a 100. However, it also said, assume that only whole number scores are given on the final, okay? So a 62 won't work. So actually, he needs to make at least a 63, okay? So 63 is his minimum score on his final. The maximum score is a 100. So Trent needs to make at least a 63 or better to pull his C for the course.